Hello everyone. So how are we today? How are you guys? We have already completed arithmetic and you solved the questions pretty well that day on the group. I'm very happy. Any issues? Hello Sima. Any issues in arithmetic as of now? Today we will be starting with number system. Nice. That's good. So today we will start a new topic which is number system, and number system is a really important topic, guys. The reason is that directly or indirectly you will get 7 to 8 questions from number system. So, and also this is a very long topic. Previously we have seen TSD, which was a very long topic. Again, this is a very long topic. So I'll just take it a bit slow so that you can grasp the concept. But this is not a topic like TSD where something is entirely new for you. You will be knowing some things, won't be knowing some things. It will be something like that. Okay. So again, this is our past results. This is our team, and today we will start number system. Let's wait for 1 or 2 minutes so that everyone can join and then we can start. So regarding number system, just wait a second. This the first lecture what I'm planning to discuss is the basics of number system, followed by what are factors. Then we will discuss about divisibility rules. Then we will discuss about cyclicity, followed by Euler's, Fermat, and so on and so on and so many things. So this should be the structure. This will be our structure. Yeah, so this will be a structure of number system. So let's start with some basic classification of numbers. What basically is number? How many types of numbers are there, and so on and so forth. The very basic classification. Okay. So see, classification goes something like this. There are 2 types of numbers. The first is real number and the second is imaginary number. So what is a real number first of all? What is a real number? Any number which can be represented on a number line is known as real number. What is a number line? A number line is nothing but a line on which there are numbers from minus infinity to plus infinity. Right? Suppose this is 0, 1, 2, 3, 4 and so on, minus 1, minus 2 and so on. This is a number line. So real numbers are any number that can be represented on this number line, like 1.1, 1.2, 1.23, 1, 2, any number. Everything is a real number. What are imaginary numbers? Now this is not in the CAT syllabus. Still, just remember this, that if I'm writing under root minus 4. Now this is an imaginary number. Why this is an imaginary number? Because in under root a negative sign cannot exist, right? Hence this is a imaginary number. So we say root of minus 1 as iota. This is a terminology that we use for imaginary numbers. Those who have given IIT-IIM, they might be very familiar with this thing. But still, this is not needed. Just the very basics I'm telling you. That iota is under root of minus 1. So I can write it as root minus 1 into root 4. That is nothing but 2 iota. There is a separate line known as imaginary line for these numbers. The vertical line. Again, it is not needed. We will not go into that. Just for clarification purpose, these are real numbers and this is imaginary numbers. Okay. Let me quickly. Fibu, are you facing some issues or you are in the session? Because I can see three times there are 3 requests from your ID. Why is this happening? Okay, anyways, Fibu, if you are facing any issues, then please check your connection because I think it is fine. Yeah, so these are real numbers and imaginary numbers. Further, let's classify real number. Now, real numbers can be rational or it can be irrational. What are rational numbers? Rational numbers are any number that can be represented in the form of p by q, where q is not equal to 0. For example, 3 by 2 is a rational number because what is 3 by 2? 1.5. It can be represented as p by q. Okay. 1 by 3 is a rational number. Again, p by q. 1 by 3 is nothing but 0.3333 and so on. Now the representation of this 0.3333 is I write it as 0.3 and bar. What is the meaning of this bar? This bar indicates that this 3 is getting repeated. Okay, so this is the meaning of this bar. This is just a way of representing it. Fine. So this is nothing but a rational number. In this, I can see that the decimals, they are recurring. Okay, this is a recurring decimal. You can see that what is recurring? Reoccurring. So this is reoccurring each and every time. So suppose if I am writing something like this, 0.125, 125, 125, 125 and so on, then what is repeating? 125 is repeating, right? So I will put a bar on 125. I will represent it as 0.125 and bar. This is the repetition part. Hence this decimal is repeating. There is some pattern to it, like 0.3333, there is a pattern. 0.125, 125, 125, there is a pattern. Okay, these are known as rational numbers. What about irrational numbers? Irrational numbers are non-recurring. There is no pattern in those numbers, right? Like for example, what is the value of root 3? It is 1.732 something something and so on. So there is no pattern here. There is no recurrence of a particular decimal digit or a group of digits, right? That is why there is no pattern as such. And this is a non-recurring number and this is an irrational number. I cannot represent this as P by Q. Now what about pi, guys? You write pi as 22 by 7, but you say pi is an irrational number. Then how you can represent it as P by Q? Anyone having any clue about it? How can I represent pi as 22 by 7 when it is an irrational number? Yeah, exactly. So that is just an approximation. The approximate value of pi is 22 by 7. If you will write pi, you will get 3.14 and something something something. So this is an endless there is no repetition. This is an endless going series. Okay. Hence this is an irrational number. This is non-terminating. Now let me again give you some example. Like, okay, let me give you a question. Write 23.23.23.23 as P by Q. Solve this. Write this down as P by Q. I'm covering this very basic part very quickly because this is the very basic, right? What is real number? What is imaginary number? What is rational? What is irrational? All these. Now I'm asking you to convert 0.232323 as P by Q. See, there is a pattern. The pattern is that 0.2323 is getting repeated. Okay, this is the pattern here. So I can definitely convert it to P by Q. So how can I do it? See, irrational is non-terminating. Rational is, we again term it as non-terminating. Now this is recurring and the other is non-recurring. That is the difference. Because in either case, the decimal doesn't terminate. Okay, Shweta? Now the question I gave was 0.2323, right? 232323, which I can represent it as 0.23 bar. This is the question that I gave. This is endless. This is going till infinity. How to solve this? There is also a shortcut that I will tell you, but the long method first, the concept one. Let x equal to this value, fine, and so on. What is repeating? 2, 3 is repeating, right? So if I just multiply this by 100, 100x becomes what? 23.23, 23, 23, and so on, right? So just I have to subtract this. That is 99x equal to 23. The value of x is 23 upon 99. Clear? Everyone? No. For those the numbers that are recurring, let's say, see, 1 by 4 is also a rational number, which is nothing but 0.25. But is anything recurring here? Or the number in which there is a repetition, those numbers are recurring if it is rational. And if it is irrational, then it is non-recurring, obviously. But yes, all recurring are rational. Correct? Now, I hope this one is correct, 0.232323. This simple thing is correct. This simple thing is clear, which is x equal to 23 by 99. I hope this is clear, everyone. Anyone having any doubt in this? How x is 23 by 99? This is very simple. Like this x equal to this, I simply multiply this by 100. There is also a shortcut to it. We will see it after some time. Don't worry. Let me take another example. Let x equal to 0.3333. You all know the value is 1.3. How you will get this? X is this. I multiply it by 10. 10x is 3.3333. So 9x equal to 3. The value of x is 1/3. Okay. So PM is asking what are terminating. Can anyone answer what is terminating? ऐसे कौन से होंगे जो terminating होंगे? Who will be terminating? I just answered this, PM, if you're paying attention. Okay. And now solve this example. Okay, you just now solve this example. I'm sorry. We saw these two examples. Solve this question. Express this as P by Q. Everyone, how we will represent it as P by Q? How to represent this as P by Q? Okay. Okay. First of all, is there any pattern here? Can I represent it as P by Q? So yes, there is a pattern. 5, 6, 5, 6, 5, 6 is getting repeated. So this is sure that I can represent it as P by Q. Now how to do it? First, let's multiply this by 10. What is the recurring part? 56, right? So let's multiply it by 10. 10x equal to what? 3.565656. Now this question is very simple. Just multiply this by 100 again. So this will be 1000x, which will be nothing but 356.565656 and so on. Again, now simple subtraction. 990x equal to 353. The value of x is 353 upon 990. Right? There is also a shortcut for it. What is the shortcut? I can represent it as 0.356 bar. Right? What is what is the part that is repeating? 0.56 is repeating. So there will be a bar on what? 56. Now, what is the integral part here? 0. First of all, write the integral part, which is 0. Just write the shortcut down. It will help you out. But the concept is very easy, but still you can write the shortcut if you want. What is the integral part here? 0 is the integral part. Write this number completely. This number is what? 356. Right? Subtract the part which is not repeating. What is the part which is not repeating? 3. Subtract 3. The bar is on how many numbers? 2 numbers. Write 2 times 9. And how many numbers are there without bar? 1 number. Write 1 times 0. This is the shortcut. If this is needed, then it is fine. If not, then this is a simple concept. This is anyway sort of oral also. So you can either follow this shortcut or you can use this concept. And you can follow this shortcut on any of these numbers. Be it this number, any of these numbers, you can follow this shortcut. Okay. Priyam, the shortcut is, first of all, write the integral part. That is the part which is on the left hand side of the decimal. So write 0. Okay. Now write this part completely. This is 356, right? I have written this completely, 356. Now subtract this 3 from here. Why this 3? Because there is a bar on 56, right? So the number that is not having a bar, subtract that number. So 3 is not having a bar, I subtracted 3. Divided by number of 9s will be equal to the numbers on which there are bar. There are 2 numbers on which there are bar, so 2 9s will be there. Okay, and there is 1 number on which there is no bar, hence 1 0 will be there. Clear, Priyam? You can apply this to this also, 0.2323 also, or you can apply this to 0.3333 also. You can apply this to any number basically. Sure. Okay, quickly do this last question, 0.619, this one, for the purpose of clarity. I'm quickly just taking this part because this is not that important. This is just the very basics. That's why I'm just quickly taking this up, and then we will move to the real numbers, which starts from factors. Express this as P by Q. Use this shortcut if you want to. 619 minus 6 will be 613 divided by 2 times 9 because on 19 there is a bar and 1 times 0 because there is no bar on 6. Answer will be 613 upon 990. The concept is same. There is a small snippet also that I have written here. You have to just remember this, that 0 is a non-negative and a non-positive number. 0 is neither a negative number nor a positive number. Similarly, 1, it is neither a prime number nor a composite number. And 2 is the only even prime number. Just remember these few things. What is the only even prime number? 2. 1 is neither prime nor composite, and 0 is non-negative and non-positive. Okay. Good question. Everyone, 0 is even or odd? 0 is even or odd. Others? What is the definition of even? Okay, let's discuss this also. From even and odd, I just remember that there we can also classify numbers as the rational numbers as integer, whole numbers, and natural numbers. Let me just quickly discuss this while you are answering this. So, what are integers? What are integers? Integers are any numbers like -1, -2, 1, 2. Basically, there is no decimal part in integers. I think you already know this. What are whole numbers? Numbers starting from 0 are known as whole numbers. 0, 1, 2, 3, 4, and so on are whole numbers. What are natural numbers? 1, 2, 3, 4, and so on. These are natural numbers. I think you already know this, but we cover this in numbers, so that's why I'm just telling you. Okay, so 0 is even or odd, guys. Many have said that even and odd applies for natural numbers. Okay, so -2, Rahul, is even or odd? -2 is even or odd, Rahul? Rahul says nothing. Okay. What about others? What is -2? Is -2 an even number or an odd number? Supriya says an even number. Okay. Okay. Achha, here I will ask you one interesting question, everyone. Let me see what is your knowledge on remainders. I am dividing 10 by 3. What is the remainder? 1. Any other remainder possible? Is 1 the only remainder that is there? Good. How many remainders are possible? 2 remainders are possible. Infinite remainders are possible. Okay. Positive and negative. Okay. See, when just look at this very basic concept. When I'm dividing 10 by 3, what I'm doing is I'm saying that this is my portion and this is my remainder. Okay. 3 3s are 9. This is my remainder. But this is the least remainder, the closest remainder I can obtain when I am maximizing this value. That is the closest, nearest remainder I can obtain when I'm taking it completely. I can also do it like this, right? 3 4s are 12, remainder is -2. What is the harm in this? There is no harm, right? I can take it as -2. There is no issue. Similarly, I can take it as 3 5s are 15 and I can write it as -5. Again, there is no issue. You cannot question me out that why I have written it as remainder as -5. I am taking this as 5. So generally, when we say remainder, that is what we are referring to as this one. Why? Because in general terms, because you always prefer to come closest to this number 10. That is completely divide this number as closely as you can, and then tell me the remainder. But there are infinite remainders possible. -5, -2, 1 can be one remainder. Or suppose if I'm dividing this at 2 times, what is the remainder? 4. 1, 4, 7. So on every difference of 3, I will get one remainder. There are infinite remainders possible. Okay. This remainder I will obtain when I'm coming closest to the value. Let's say this value is n. So when I'm coming closest to n, this is the remainder that I will obtain. The least positive remainder that I can obtain is this number, that is 1. But there are infinite remainders possible. This is the very basic of remainder. I hope this is clear to you. Now you will tell me whether 0 should be even or odd and whether -2 should be even or odd, or neither. Now tell me about this, but not now. Just think over it and then tell me. Okay. Yeah. So let's see how to determine whether a number is prime or not. What are prime numbers? What are prime numbers? The numbers that are having 1 as a factor and itself as a factor. Like for example 5. So 5 is having 1 as a factor and 5 is also having 5 as a factor, right? And apart from these two factors, there are no other factors of this number 5. Hence this is a prime number. What about 6? What are factors, by the way? Factors, any number that is completely dividing this number n is known to be a factor of this number. What about 6? 1, 2, 3, 6. There are 4 factors. 4 numbers can completely divide this number 6. Hence, what is the meaning of complete division? That remainder will be 0. Now there are many prime numbers, guys. Prime numbers are endless. Okay? There are infinite prime numbers that we are having. So how to determine whether a number is prime? There should be some easy method, right? But let me tell you, this method is a rejection method. It is an elimination method, not a selection method. How so? Let us see. First of all, suppose if I am asking you whether 239 is a prime number or not, is 239 a prime number or not? This is my question. The ideal way that you should do is check for the divisibility below root 239. This is the ideal way that you should do. The ideal way I'm talking about. Okay. If it is divisible by any number that is less than equal to root 239, then this won't be a prime number, else it will be a prime number. This is the basic way. Because see, you should divide by each and every number from 1 to 238. But even if you're dividing by it by root 239, the numbers below root 39, you can obviously say that it will be divisible by the numbers which are beyond root 239. Priyam, I won't answer this question right now, why I am taking this route. When I will tell you something known in factors, I'll teach you something known as multiplication. Then I'll address this query. Hold on. As of now, just remember that why root 239. That we always take root. Okay. Good, Shweta. Yeah. Okay. So we take root 239. Okay. This is not divisible, hence this is a prime number. But this is a very long method. You cannot check by each and every number. Like root 239 will be something what 15 to 16. So I have to check by each and every number 2, 3, 4, 5, 6, 7, 8 till 15. So this is a very tedious method. So what can I do? So let's make this easy. This is making it easy. How to determine a number is prime or not? You can do this by two simple methods. Any prime number, just remember this thing, that any prime number will be of the form 6k plus minus 1. Any prime number is of this form only, 6k plus minus 1. But converse is not true. For example, any number prime number obviously which is greater than 3. Example, 5 is a prime number, right? 7 is a prime number. 11 is a prime number. 13 is a prime number. 19 is a prime number. 25 is not a prime number. Now see what is happening. This is a prime number. It is of this form, 6k minus 1. This is a prime number. This is of this form, 6k plus 1. Prime number, 6k minus 1. Prime number, 6k plus 1. Prime number, 6k plus 1. And in this way it goes. But if a number is of the form 6k plus 1, I cannot say a number is prime. So what I can say is, if a number is prime, then it will be definitely in this form. This is what I can say. But if a number is in this form, then it is prime. This I cannot say. What is the meaning of 6k plus 1 or 6k minus 1? That whenever I will divide that number by 6, the remainder that I will get is either 5 or 1. This is the meaning of number being in the form of 6k plus 1 or 6k minus 1. First point clear? Point number 1 clear, everyone? Any doubt? Anyone in point number 1? Anyone? See, this is nothing but I am saying that if a number is prime, then it will follow this rule of 6k plus 1, 6k minus 1. But if a number is not prime, then good, everyone. If a number is not prime, then it can follow, it cannot follow. But a prime number will definitely follow this rule. Second is, digital root of a prime number can't be 3, 6 or 9. Anyone aware about what is digital root? Digital root? Anyone? Any idea what is digital root? Yes, we also term it as digital sum. What is digital sum? Let's take a number 583. Path says sum of digits. Is it sum of digits? Let's take 583. Yeah, till single digit. Good. Let's take 583. What is the sum of sum 8 plus 5 plus 3? That is 16. Again, I will sum 1 plus 6. This is 7. So I will take sum of digits till a single digit. Okay. This is known as a digital sum. Okay. Now this digital sum of a prime number, it can't be 3, 6 or 9. So you will remember two things if you want to check a number is prime or not. First of all, the number should be of this form, number 1. Number 2, digital sum cannot be 3, 6 or 9. Okay. Now how to calculate the digital sum also? Every time you cannot go on adding till single digit. So a digital sum is nothing but mod 9. That is a remainder. What is the meaning of mod? What is the meaning of mod? So mod is in functions, there is a function known as modulus function. That is different. And this is mod. If I'm writing, let's say 15 mod 4, the meaning is if I'm dividing 15 by 4, what is the remainder? What is the remainder? Minus 1. Or I can also write the remainder as 3 as per my wish. So 15 mod 4 is minus 1, or I can write it as 3. Okay. So digital root or digital sum is nothing but mod 9. Let's check this out. What is this? 15. What is 15 mod 9? 15 mod 9 is 6. What is 5 plus 1? 6. Digital root is nothing but number mod 9. Okay. Ayush, at times you will see that suppose this is Arpit. Repeat what, Arpit? The first part, the second part. Okay, Arpit. Second part is I talked about digital root. What is the digital root or digital sum? So digital root or digital sum is nothing but sum of the digits. I hope this is clear, Arpit. Then I told there can be a short method. The short method is just taking the remainder by 9. So what will be the remainder when 15 will be divided by 9? Remainder will be 6. And digital root will be 6. Okay, Arpit. Mod function is nothing but what will be the remainder obtained when 15 is divided by 9. So just take this 5 plus 1 is what? 6. Okay. So digital root of a prime number can be 3, 6 or 9. Shweta is asking, it is just eliminating the divisibility by 3. Is it so? Is it eliminating the divisibility by 3? If a number is divisible by 9, then is that number automatically divisible by 3? Is that the case? Suppose there is a number which is divisible by 3. Is that number also divisible by 9? Few are saying yes, few are saying no. Obviously, it should be no, right? Obviously, it should be no. Because see, what about 15? 15 is what? 3 into 5. I just took this number 15, right? So this is divisible by 3. But is it divisible by 9? This is not divisible by 9. So we are not eliminating the divisibility of 3. Yeah, that we will learn in divisibility. Let's leave it to divisibility. Now this is just an elimination trick. How to apply this trick? Try this question. Answer me, which of these is a prime number? Again, this is an elimination trick, just remember it. Not a selection trick. Try it out. Everyone. Just see those conditions and just try it out. Okay, good everyone. Others also, I've just told you these two methods, that it should be 6k plus minus 1, right? So if you're dividing by 6, what you will get as remainder? Either 1 or 5. And if that number is a prime number. And digital root can't be 3, 6 or So let's check this option out. No, Priyam, we cannot do it only by digital because, see, okay, let's take digital sum of these numbers. Priyam, quickly tell me the digital sum of A, B, C, and D. What is the digital sum of these numbers? You might get a question in which two numbers are having digital sum, let's say 1 and 1. So this will again serve it as an elimination method. Like one, the first point will serve it as an elimination method. There might you might get something like this also, in which both these conditions are not getting satisfied. In that case, you cannot determine it unless and until you take the root of this number. But you won't get that question in that. Don't worry. If they are giving something on prime number, they are expecting this only from you. Okay, because this is an elimination trick, not a selection trick, as I have just told you. Right? Yes, Priyam. So this is 3, so it can't be 3. And you said that this is 0. Okay. And okay, if this is 0, then can this be a prime number? Priyam, again, see what we are getting digital. What are we getting digital sum of this A? We have to use both of these things. Suppose if I'm getting digital sum as 0 of one number, okay, and I'm getting digital sum of 2 as of other number. Can I differentiate between these two, Priyam? I cannot differentiate. So then my first one, that is the mod 6, should be 1 of 5. This will come to my rescue. Even if this is also getting satisfied, okay, this is also good. Then also, if even then I'm unable to differentiate, such questions won't be asked because you will always use this elimination trick. It is not a selection trick. Clear, Priyam? So you can use either of them to start with, but you should use both of them to confirm. Okay. Yes, it has to be 6k plus minus 1. Exactly. Chalo. Next thing now. Okay. Just look at the snippet below. That's a very important information on prime numbers. Learn this information. Also, I will tell you a good trick to learn this. What it is saying is number of prime numbers from 1 to 30. How many prime numbers are there from 1 to 30? So there are 10 prime numbers from 1 to 30. How many prime numbers from 1 to 50? 15. 1 to 100? 25. 1 to 200? 46. 1 to 1000? 168. Okay. This is what this information is saying. How to learn this? Now this is just a trick and it will work for few numbers only. Divide 30 by 4. Divide everything by 4. So 100 by 4 is 25. You will directly get the answer. What is 50 by 4? 50 by 4 is greater than 10 but less than 15. So look for the higher multiple of 5. Again, it is just a learning trick. There is nothing involved here. This is just a trick to learn this. You have to learn this anyways. Okay. So what is 50 by 4? This is something less than 15. Take the nearest multiple of 15, which is 5, which is 15. Again, 30 by 4, something less than 10. So again, take the nearest multiple as 10. When you will go to 200, this rule won't work because 200 by 4 is 50. So you have to learn it something like this: 50 minus 4, which is 46. This is just a trick to learn these numbers, that you don't forget these numbers and nothing else. Okay, just remember these numbers. Right? 1 to 1000, 168. Now let's see a question how to apply this knowledge. Solve this question. What is factorial, by the way? This symbol, the symbol of factorial. What is factorial? 10 factorial is nothing but 1 into 2 into 3 into 4 till 10. This is 10 factorial. Okay. The meaning of factorial is 1 till that number. Okay, now tell me the answer to this question. What will be the answer? Okay, I'm getting two answers, 46 and 47. Others, please quickly try this out. Mukul says 47. 4 also, nice. This 4, the concept of this 4 is very hard to click on the first row. You might have seen this question earlier as well. Or if it has clicked right now, then it is very good, because 4 is an exception. Okay, so what is the question? How many natural numbers? Yeah, exactly. How many natural numbers n below 200 such that n minus 1 factorial is not divisible by n? So what is this talking about? N minus 1 factorial should not be divisible by n. So it is simply indicating me to find prime numbers. Prime numbers below what? 200. So how many prime numbers are below 200? 46 prime numbers are below 200. Okay. So n minus 1 factorial will not be divisible by n. Let's take an example. 5 factorial upon 6. What is 5 factorial? 1 into 2 into 3 into 4 into 5 divided by 6. So this is divisible, right? Here I have taken n as a composite number. So if it is a composite number, then this will be followed. But if this is a prime number, let's say, let me take n as 5. What is 4? What is 5 factorial? 1 into 2. What is 4? Sorry, what is 4 factorial? 1 into 2 into 3 into 4, right? And upon 5. N minus 1 factorial is 1 into 2 into 3 into 4 upon 5. This is not divisible. Okay. This is simply asking why, because I know that the factors of a prime number are only 1 and the number itself. That is why it is not divisible. Hence, this question is asking me to calculate prime numbers. Now, what are the prime numbers? There are 46 prime numbers below 200. Okay. And 4 is an exception to this rule. You just have to remember this. Because 4 is what? 1 into 2 into 3 upon, if let's say n is 4, then 3 factorial 1 into 2 into 3 upon 4. This is also not divisible. Although 4 is not a prime number, but this is not divisible. Hence, answer is not 46 but 47. Supriya, this was the previous slide.